General Motors temporarily shutting down more than half of its plants in North America.
It didn't start with a recall notice. It didn't start with angry customers or viral videos. It started quietly, inside a testing room where brand new engines are supposed to prove they're ready for the road. General Motors, one of the largest automakers on Earth, is now facing a crisis that analysts say could reshape the entire North American auto industry. Plants have gone quiet. Production schedules have fractured. Executives are holding emergency meetings behind closed doors. And buried at the center of it all is an engine that was supposed to define GM's future, but instead exposed a failure so deep, so systemic, that it triggered a chain reaction no one inside the company could stop. This wasn't a minor defect. This wasn't a bad batch. This was a breakdown that reached into manufacturing, supply chains, dealerships, financial markets, and even global trade dynamics. And when a company the size of GM stumbles like this, the consequences don't stay contained. They ripple outward, hitting workers, suppliers, investors, and everyday drivers who may never have owned a GM vehicle in their lives. What makes this situation especially alarming is where the failure happened. Not on highways, not after years of wear, but at the very beginning, before these engines ever reached customers. A flaw discovered at birth. One that suggested the problem wasn't just a component, but the process itself. As the fallout accelerates, competitors are moving fast. Foreign automakers are stepping into the gaps. Wall Street is whispering words that haven't been spoken openly in years, and the cost of this failure is already starting to show up in higher prices, longer repair times, and growing uncertainty across the entire automotive landscape. This is not just the story of a bad engine. This is the story of how a single manufacturing flaw turned into a billion-dollar disaster, and why the next phase of this crisis could affect far more than just General Motors. And it all began with an engine that never made it out of the lab. Real quick, if you're into videos that cut through the noise and break things down clearly, go ahead and hit that like button. It helps more people find this. And if you're not subscribed yet, now's a good time. We've got more deep dives coming your way. Also, drop a comment and let me know what you think. I'd love to hear your take. Now onto the video. The L87 engine was supposed to be one of General Motors' quiet successes, a modern V8 designed to carry the brand forward, more efficient, more refined, and engineered to meet the demands of a new generation of trucks and SUVs. It wasn't marketed as experimental. It wasn't rushed. This engine was meant to represent continuity, reliability, and GM's deep confidence in its manufacturing systems. That's why what happened next stunned everyone who saw it. Before an engine ever reaches a vehicle, it must pass a series of tests designed to expose flaws invisible to the human eye. One of the most critical is the pico vibration test, a precision procedure meant to detect microscopic imbalances that could cause long-term failure. Engines that pass it move forward. Engines that fail, it don't get a second chance. When the L87 was tested, the results weren't borderline. They weren't ambiguous. The data spiked so sharply into failure territory that engineers reportedly stared at the readouts in disbelief. This wasn't a deviation, it was a rejection. What made it worse was the engine's appearance. On the outside, everything looked perfect. The intake ports were clean, pistons showed no visible damage, lubrication surfaces appeared smooth and untouched. By every traditional inspection standard, the engine looked flawless. But the pico test doesn't care about appearances. It listens to the machine, and what it detected set off alarms. In a company built on mass production discipline, an engine failing at birth is more than embarrassing, it's terrifying. Because early-stage failures don't point to wear or misuse. They point to something far more dangerous, a flaw baked into the manufacturing process itself. Engineers quickly realized this wasn't an isolated unit. If one engine failed this decisively under controlled conditions, others were likely carrying the same hidden defect. That realization shifted the mood from confusion to urgency. What had looked like a single anomaly began to resemble a systemic contamination, one that could affect entire production runs. Internally, the language changed. This wasn't a quality issue anymore. It was a process failure, the kind that doesn't just break parts, but undermines confidence in every engine already built. And as engineers dug deeper to find the source of the failure, they uncovered something almost invisible. A defect smaller than a grain of dust, but powerful enough to set off one of the most expensive mechanical crises General Motors has faced in years. Because what they found next wouldn't just explain why the engine failed. It would explain why so many more were already doomed. When engineers began investigating why the L87 failed so catastrophically during vibration testing, They didn't find cracks, fractures, or obvious defects. What they found was far more unsettling, because it was nearly invisible. The problem was buried in the crankshaft journals, the polished surfaces where metal meets motion, thousands of times per minute. On paper, the numbers looked reassuring at first. The roughness average, known as RA, appeared well within acceptable limits. Under traditional inspection standards, this crankshaft would have passed without raising suspicion. But another measurement told a very different story. When engineers examined the RZ value, a metric that measures the height of microscopic peaks and valleys across the metal surface, the data exploded off the charts. The surface wasn't uniformly smooth, it was jagged, violent. In microscopic terms, it looked calm from a distance, but chaotic up close. Those tiny ridges mattered more than anyone expected. Each peak acted like a blade, scraping away the protective oil film that separates moving metal parts. Instead of gliding smoothly, the crankshaft was slowly grinding itself down with every rotation. Oil couldn't replenish fast enough. Friction multiplied. Heat followed. This wasn't a modern engineering mystery. It was a violation of the most basic principles of tribology, the science of friction, wear, and lubrication. And that's what made it so humiliating. GM wasn't dealing with bleeding-edge complexity. It was dealing with a surface finish problem that modern machining processes are specifically designed to prevent. The implications were immediate and devastating. If the surface finish was wrong, it meant the issue likely originated upstream, at the machining or finishing stage, long before final assembly. Hundreds of thousands of crankshafts may have already been produced with the same hidden flaw. By the time the data reached senior engineering teams, it was clear this wasn't just about failure risk, it was about inevitability. Engines built with this surface geometry weren't a question of if they would fail, but when. And just as alarming as the metal itself was what happened when that flawed surface encountered something it depended on to survive, flowing oil. The real catastrophe began when the flawed crankshaft surface met the lubrication system that was supposed to protect it. Under normal conditions, oil forms a thin but resilient film between the crankshaft journals and the bearings that cradle them. That film absorbs load, prevents direct metal contact, and allows engines to survive hundreds of thousands of miles. But in the L87, the geometry itself sabotaged that process. Engineers discovered that oversized chamfers, angled edges cut into the crankshaft journals, were allowing oil to escape sideways instead of staying where it was needed most. Instead of forming a stable cushion, lubrication was bleeding away with every rotation. On a perfectly machined surface, brief drops in oil pressure might be harmless, but combined with the jagged surface finish already scraping away oil faster than it could regenerate, those pressure losses became lethal. The engine wasn't fully starving all at once. It was starving in pulses, tiny moments of lubrication collapse repeating thousands of times per mile. When failed engines were opened, the damage told the story clearly. Bearings showed ripple-like wear patterns, evidence of oil surging and collapsing in irregular waves. This wasn't random failure, it was rhythmic, predictable, systemic. The lubrication system itself wasn't broken, it was overwhelmed, forced into constant recovery mode, fighting a battle it could never win against flawed geometry and surface texture. No amount of assembly precision could compensate for oil that refused to stay in place. What stunned engineers most was how quietly the defect advanced. Early production engines carried the flaw undetected, operating normally until they suddenly didn't. Some locked up without warning, others degraded internally, long before drivers noticed anything wrong. By the time field reports began stacking up, the problem was no longer theoretical. It was already embedded across the production fleet. And when those findings finally reached the executive level, the crisis shifted from engineering failure to corporate emergency. Because at that moment, GM leadership realized this wasn't a recall they could quietly manage. It was a structural failure, threatening the foundation of the company itself. When the full scope of the findings reached General Motors' executive floor, the response was immediate and tense. GM had weathered recalls before. The company understood public pressure, regulatory scrutiny, and warranty costs. But this failure was different. It didn't originate from suppliers. It wasn't caused by external disruptions. It came from inside the most protected and trusted part of the organization, the engine program. Machining inconsistencies, surface finish violations, lubrication collapse, production units already deployed. Each page expanded the radius of impact. What began as an engine issue now threatened multiple vehicle programs, manufacturing schedules, and long-term development timelines. Meetings stretched late into the night as leadership debated containment strategies. One group pushed for aggressive recalls and transparency, arguing that delay would only magnify reputational damage. Another warned that acknowledging the full scale of the defect could rattle investors, trigger downgrades, and destabilize the stock. Behind the debate was a deeper fear. Trust in GM's manufacturing discipline had been compromised. If this defect slipped through undetected, what else might be lurking beneath the surface? The crisis wasn't just mechanical, it was existential. Executives also faced a brutal reality. Fixing the problem wouldn't be fast. Remachining crankshafts, correcting chamfer geometry, validating new production runs, all of it required time GM didn't have, and everyday production slowed or stopped. The cost climbed higher. As discussions intensified, one outcome became unavoidable. The disruption would spill beyond corporate offices and engineering labs. It would hit factories, workers, communities, and when production lines finally went quiet, the human impact of this failure became impossible to ignore. The first sign that the crisis had moved beyond engineering came in the form of silence. Factories that normally vibrated with motion, conveyors humming, presses pounding, engines rolling steadily down the line, went quiet without warning. For workers on the floor, the stillness felt wrong. Unplanned shutdowns rarely arrive without consequences, and everyone knew it. Supervisors walked the aisles with clipped instructions and guarded expressions. Machines sat frozen mid-cycle. Half-assembled engines remained suspended in place, waiting for decisions being made far above the factory floor. Official explanations were vague. Temporary pause, safety review, process verification. But the lack of clarity only deepened the unease. For many workers, these plants weren't just jobs, they were lifelines. Entire communities were built around their operation, with families depending on predictable shifts and steady paychecks. A sudden halt didn't just interrupt production, it interrupted certainty. Rumors spread quickly. Some workers whispered about massive recalls, others feared layoffs or extended furloughs. Veteran employees who had lived through past downturns recognized the signs immediately. This kind of stoppage rarely resolved itself quietly. What made the situation worse was the scale. This wasn't a single facility adjusting a line. Multiple plants across North America were affected, creating a sense that something far bigger was unfolding. The engine program had stalled, and with it, a key artery of GM's production network. As days passed, anxiety replaced patience. Workers checked phones during breaks, waiting for updates that never came. For many, the shutdown wasn't just about lost hours. It was about the fear that the system they trusted was breaking down. And while factory floors stood still, the shockwave surged outward to the next link in the chain, suppliers whose survival depended on uninterrupted motion. The moment suppliers received notice that production had paused, the damage spread faster than anyone expected. Modern automotive supply chains operate with almost no margin for disruption. Parts arrive just in time. Schedules are calibrated down to the hour. When GM's lines stopped, that precision collapsed instantly. Casting facilities found pallets of unfinished crankshafts stacking up near loading docks. Machining shops scrambled to delay shipments already en route. Managers called emergency meetings trying to slow production without triggering contractual penalties or labor conflicts. For smaller suppliers, the situation was especially dangerous. Many relied on GM volume to keep their operations afloat. Even a brief pause threatened cash flow, payroll, and long-standing workforce stability. Forklifts sat idle. Welding crews were reassigned or sent home early. Overtime disappeared overnight. The frustration cut deep because these companies hadn't caused the failure. They had met their specifications, delivered on time, followed the rules. Yet they were now absorbing the fallout of a defect they had no control over. As uncertainty dragged on, tensions grew. Suppliers pressed for answers. GM couldn't provide timelines. Delivery commitments were rewritten again and again. Some facilities began preparing furlough plans they hoped they wouldn't need. The ripple effects reached logistics providers next. Trucks were rerouted, shipments delayed, warehouses overflowed with parts that suddenly had nowhere to go. What had once been a finely tuned machine now felt unstable and reactive. And as suppliers struggled to adapt, the consequences reached the most visible and volatile frontline of the crisis. Dealerships forced to face customers without solutions. The first tow truck arrived before sunrise. By mid-morning, service bays were full. Engines had failed on highways, in driveways, and during routine commutes. Vehicles that were days or weeks old were suddenly immobile. And for dealership staff, the pattern became painfully clear. This wasn't an isolated issue. Dealerships were used to recalls. They were used to frustrated customers. But this was different. Engines weren't just malfunctioning, they were failing outright. and the parts needed to fix them weren't arriving. Technicians worked through breaks, diagnosing vehicles only to reach the same conclusion over and over again. Engines required replacement. Replacement engines were unavailable. Service managers tried to keep calm, explaining delays with rehearsed patience, but every explanation pushed tempers closer to the edge. Customers demanded loaners. Some demanded refunds. Others demanded answers the dealership simply didn't have. Employees found themselves trapped between corporate silence and community outrage, absorbing anger that wasn't truly directed at them. The atmosphere changed. What had once been places of routine maintenance turned into crowded rooms filled with tension, disbelief, and exhaustion. Families missed work. Travel plans collapsed. Trust eroded quickly. Then came the cameras. Drivers began recording their experiences. Tow trucks lined up outside service centers. Videos of stalled vehicles and packed waiting rooms spread across social media, transforming individual breakdowns into a collective narrative of failure. And once those stories escaped into the public eye, the crisis entered a phase General Motors could no longer control, one driven by outrage, exposure, and a growing sense that something far bigger was unraveling. The crisis truly escaped General Motors' control the moment it went online. It didn't begin with an official statement or a press conference. It began with a single video, a driver standing on the side of the road, filming a brand new truck that had shut down without warning. The caption was short, the footage was raw, and within hours, it was everywhere. More videos followed. Different states, different models, same outcome, engines dead, tow trucks arriving, drivers asking the same question over and over again. How could something this new fail this completely? Social media did what it does best. It connected isolated incidents into a single powerful narrative. Owners who had never met began comparing notes in comment sections and forums. Patterns emerged. Similar symptoms, similar timelines, similar frustration. What once looked like bad luck now looked like a systemic failure. Online communities that had previously celebrated GM's trucks and SUVs flipped almost overnight. Brand loyalty eroded in real time. Long-time owners who once defended the company now felt betrayed, sharing stories of missed work, cancelled trips, and vehicles they no longer trusted to keep their families safe. Dealership footage amplified the anger. Videos showing rows of immobilized vehicles and packed service waiting rooms went viral, reinforcing the image of a company overwhelmed by its own mistake. Media outlets took notice, contacting affected owners and broadcasting their experiences far beyond automotive circles. What made the backlash especially damaging was GM's response, or lack of one. Official language was careful, slow, legal, to customers demanding clarity and urgency. It felt detached. The gap between expectation and response widened until outrage hardened into distrust. This wasn't just a recall anymore. It was a public reckoning, and as attention intensified, another group began watching closely, one that reacts not with emotion, but with capital, Wall Street. Because when confidence collapses at the consumer level, financial markets tend to follow, and the signals investors were starting to see were deeply unsettling. General Motors has faced crises before, but this one is different. This failure didn't come from an economic downturn or a sudden collapse in demand. It didn't arrive through a supplier dispute or an external shock. It emerged from inside GM's own manufacturing system, at the core of its identity as an automaker. What began as a microscopic surface defect cascaded into plant shutdowns, supplier instability, dealership chaos, public revolt, and growing financial anxiety. Each layer of the system exposed how tightly interconnected modern manufacturing has become, and how quickly a single flaw can destabilize the whole structure. The long-term consequences are still unfolding. Competitors are already moving to capture displaced customers. Foreign automakers are stepping into gaps once assumed to be secure. Investors are reassessing assumptions that held steady for decades. And everyday drivers are absorbing the cost through higher prices, longer waits, and fewer choices. For GM, the path forward is narrow. The company is racing to correct manufacturing processes, restore trust, and accelerate its push into electrification and next-generation mobility. Battery partnerships, software platforms, and autonomous ambitions now carry even more weight, not as growth strategies, but as survival strategies. Whether this moment becomes a painful lesson or a turning point depends on what comes next. Transparency, accountability, and the ability to prove that the systems meant to ensure reliability can still be trusted. Because in today's automotive world, reputation moves faster than production lines. Once trust is lost, it's not easily rebuilt. And the question hanging over General Motors now isn't just about engines or recalls. It's about whether one of the world's most iconic automakers can adapt quickly enough to regain control of a story that has already reshaped its future. Is this the beginning of a comeback, or the early stages of a long decline? That answer won't be decided in a lab or a boardroom alone. It will be decided by drivers, investors, and markets watching closely to see what GM does next. Once again, thanks for watching this video. If you got something out of this, hit that like button and make sure you're subscribed so you don't miss the next one. And hey, let me know your thoughts in the comments. Agree, disagree, or something in between. I'd love to hear it.